Hello, good evening, Charu. Good evening, Pratham. So now today we are going to start the fourth chapter, which is pressure in fluids and atmospheric pressure. Right? We have completed the first three chapters. We have done all exercises also. So now we start the fourth chapter. I had told you that in case you have any issues in the previous chapter, you can always write to me. Nobody wrote anything to me, which means you don't have any doubts. Everything is clear. We had an open session also in this. So let's start with the fourth chapter, pressure in fluids and atmospheric pressure. Okay, so the first thing which we have to understand is thrust and pressure. Okay, all of you have understood force. Okay, we have studied about force and we know what force is. What is force? Can you please tell me? Some of them are still joining, so in the meantime you can, the ones who have joined, Pratham, Charu, you can tell me what is force. We studied about force in the previous chapter. Quickly write in short and send it to me. Till the meantime others will also join in. I'll give you a hint. Okay, we say that a push or a pull can be classified as a force. Okay. So they won't be coming. So you can answer. You haven't answered. PTM. Okay. So we have classified force as a push or a pull. Okay. I mean, it brings about a change in the velocity. It either brings a moving body to a stop, or it increases the velocity of a moving body, or it brings a stationary body into motion. Okay, so if that is force, then what is thrust? Okay, thrust is the force acting normally on a surface. What do I mean? Okay, now I have a surface like this. Okay, and I could have the force acting on it in any direction. I could have a force acting like this. I could have a force acting like this. Okay, so these are not called thrust. Okay, if I have forces acting like this, okay, which are not perpendicular to the surface, then I don't call it thrust. But if I have a force which is acting absolute perpendicular, okay, which is acting absolute perpendicular to the surface, then such a force is called thrust. Okay, so it is nothing but a force which is acting at 90 degree to the surface. Okay, and both of you couldn't write to me what force is. We have completed the chapter, so that's very bad. So please revise today. Next class when I come, I'll ask you again, so then you should be able to write it to me. Okay, so thrust exerted by a body. Now I suppose I take the same surface. Okay, I take the same surface, and now I keep a brick on top of it. Okay, I keep a brick on top of it. So now is this brick exerting any thrust on the surface? Is this brick exerting any thrust on the surface? Okay, we know that suppose that the mass of this brick is m, okay, and we know that the acceleration due to gravity is g, small g. Okay, so at the center of gravity of this brick, the weight of this brick will be acting, which will be equal to mass into gravity. Okay, that will be the weight acting at the center of gravity, and of course it will be perpendicular to this surface. We name it PQ. Okay, so it will be perpendicular to this surface. So the thrust is the force which is acting normally to the surface. So in this case, it is the weight of the brick which is acting perpendicular to the surface. Okay, now it's a vector quantity. As you can see that the force of gravity or the weight of this body, it will be always be acting towards the center of the earth. Okay, so thrust also is a vector quantity. Got it? It's a vector quantity, which means it has both magnitude as well as direction. Recording, so I've purposely switched it off. Okay, so it's a vector quantity. Everybody understood? So now next we go to find out what will be its unit. Okay, since it's a force, it's just a force which is acting perpendicular, so the SI unit will be same as that of force. So what is the unit of force? The unit of force is Newton. Okay, the unit of force is Newton. So we have found out that 1 Newton, okay, 1 Newton, the definition is that 1 Newton of force is the force which brings about an acceleration in a body of 1 kg. The acceleration is 1 meter per second square. This definition we have already studied in the previous chapter. Okay, so if I go in terms of the CGS system, okay, then the CGS system is dyne. And how many dynes is 1 Newton equal to? 1 Newton is equal to dyne is gram per centimeter square. So we change kgs into grams, so it becomes 1000 grams, right? And I change meter into centimeters, so it becomes 100 centimeters. Got it? And second square stays as such. So which means that 1 Newton is equal to 1, 2, 3, 4 and 5 gram centimeter per second square. Okay, which means 1 Newton is equal to 10 to the power 5 dyne. Clear? Very simple. This was a revision. We have already done it. Okay, so now since thrust also is a force after all, which is acting perpendicular, so its units also will be the same. Okay, then we have the gravitational unit also. Okay, we have the gravitational unit. We have the gravitational unit. And what is the gravitational unit? The gravitational unit is kgf. kgf. Okay, and how much is that equal to? 1 kgf is equal to 1 into 9.8 newtons, which means it is equal to 9.8 newtons. So 1 kgf is equal to 1 kgf is equal to 9.8 newtons, whatever the mass multiplied by the gravity. Okay, and we convert it into newtons, that many newtons. Okay, if it is in the CGS system, then it becomes 1 gf, and 1 gf is equal to 980 dynes. Everybody understood? So that finishes our discussion on thrust. We spent quite some time. We understood that thrust is the force which is acting perpendicular to a surface. Okay, now next we go to something known as pressure. Before we go into liquid pressure, let's understand once again. You've studied in your junior classes. Let's understand once again what is pressure. Okay, now in the previous case where we drew this brick, okay, where we made this brick, okay, if I keep the brick like this, and on the other hand, I could have kept the brick like this. I'll just extend the yellow line first a little. Okay, I extend the yellow line, and now I say that instead of keeping the brick like this, I keep it this way. Keep it this way. Okay. So now you tell me, okay, is it going to exert the same amount of pressure here, and is it going to exert the same amount of pressure there? Okay, the weight which is acting remains the same. Okay, now suppose you put a lemon or a small raspberry under this brick. Okay, is it going to be crushed to the same extent? Is it going to be crushed to the same extent? You reply to that question, and I move forward till then. Okay, now I till the time you answer, I bring in another example. Okay, now I have this nail over here. I have this nail, and this is the pointed end, and I have a board underneath it. I have a board underneath it, and on the other hand, what I do is I invert the nail. I invert the nail. This time I make the head down like this, and I keep the nail upside down. I keep the nail upside down this time like this. Oops, I'm so sorry. My hands are not being able to draw. I'll draw it from top to bottom, then it goes well. Okay, so this time I keep the nail like this. The pointed end is up, and I hammer in both the cases. Okay, I hammer this nail, which means I apply a force. Okay, and this has to, let's see what happens. Both the cases I hammer it. Will the nail go into the board in both the cases? I didn't get any answers from you till now. I didn't get the answer. So you both of you are not answering, just listening to me. It would be better if you could reply. I would understand whether you're learning or not. Okay, so now I apply a force on it. Okay, and if you see that this nail goes in, okay, it penetrates the board, but this nail doesn't go in. Now the question arises that the thrust, okay, or the perpendicular force which I applied is same, and the nail also is same. Okay, then why in this case it goes into the board and in this case it doesn't go? Okay, then I see that whatever thrust I applied, okay, it got concentrated. It got concentrated over here on a very small point. Okay, it got concentrated on a very small point, whereas whatever thrust I applied, now it got distributed over a wider area. It got distributed over a wider area. Okay, and hence this nail was able to go in and this nail couldn't go in, because here the thrust, it got distributed. Okay, so we come upon something now which we represent by a P. Okay, and this is called pressure. So pressure is what? It is thrust upon area. Okay, it is thrust upon area. So we can say that the thrust is same. Okay, suppose that the thrust here was I represent it by a force F. It was F. So here also it is same F. Okay, and I change. What do I change? I change the area. Okay, here the area is small and here the area is big. Okay, so when I change the area, what happens? I see that the nail goes in this case. Okay, which means the pressure was greater, and in this case the nail doesn't go in because the pressure was smaller. So you can see that the greater the area, the bigger the area, the lesser is the force, and the lesser the area, the bigger is the pressure. So I said force here, I'm so sorry, pressure. So greater the area, lesser is the pressure, and lesser the area, greater is the push. Pressure. Greater the lesser the area, greater is the pressure. Everybody understood this? Okay, so now we can write what is pressure. If I remember this, okay, and they ask me what is pressure, I can say that pressure is the thrust. Pressure is the thrust per unit area of surface. Okay, so you can see that the surface in contact over here was almost equal to a small point, and here it was a bigger sheet. Okay, so the pressure here is greater and the pressure there is lesser. Very nice. Pratham says understood. Arnav, when did you join? Okay, welcome to the live class. Joined very late. Okay, so now we go to find out the unit. Now that we have understood what pressure is, let's find out what is the unit of pressure. We have understood that pressure is equal to force or thrust, to be exact, by area. Okay, this is, you know, that force is unit is Newton. Okay, so it becomes Newton, and area's unit, you know that it is meter square. Okay, so pressure becomes Newton per meter square. Okay, the unit of pressure is SI unit is Newton per meter square, which in honor of physicist Pascal, we have named it Pascal, and we represent it by a P followed by a small a, or we can write a small p and followed by ASCL, Pascal, to write the full name. Okay, so 1 Pascal is equal to 1 Newton by 1 meter square. This will give you the definition. If they ask you to define 1 Pascal, what is 1 Pascal? Then we say that the pressure is said to be 1 Pascal when a thrust of 1 Newton is acting on an area of 1 meter square. Are we clear? 1 Pascal is the pressure exerted on a surface of 1 meter square by a thrust or a force of 1 Newton acting normally. Clear? Everybody understood? Okay, we move forward. Okay, so that's the SI unit. Suppose I had to find the CGS unit. If I had to tell you the CGS unit of pressure, then what it would be? Okay, now we know that in CGS unit force, the force CGS unit of force is dyne. Okay, so it becomes dyne, and the unit of area now would become centimeter square. So now it becomes dyne per centimeter square. Okay, dyne per centimeter square. Okay, and if it is measured in GF. Okay, very nice. Pratham says understood. Charu also says understood. Very nice. So it becomes dyne centimeter. Now there are some other units also. Okay, if I have to measure a bigger pressure, okay, if I have to measure big pressure, okay, then I've got some bigger units also, and they ask you sometimes in the examination. I had seen one of the years they had asked. Okay, so what is the bigger unit? The bigger unit is bar. The bigger unit is bar. Okay, and what is 1 bar equal to? 1 bar is equal to 10 to the power 5 Newton per meter square. Okay, which means if the pressure is 1, 2, 3, 4, 5, these many pascals, if the pressure is these many pascals, then we call it 1 bar. Okay, So if the pressure is 10 to the power 5 Newton meter square, it is known as 1 bar. Okay. We also have, we also have millibar. Okay. Now what is millibar? We also have millibar. Okay. Now milli we know that means 1 divided by 1000. Okay. Or 10 to the power minus 3 is known as milli. So which means that millibar, 1 millibar should be equal to 1 by 1000 of 1 bar, right? And we know that 1 bar is equal to 10 to the power 5 Newton per meter square. Okay, so if I am dividing it by 10 to the power 3, then exponents, it becomes 10 to the power 5 minus 3, which means it is 10 to the power 2 Newton per meter square. Got it? Or 100 pascals. So 1 millibar is equal to 10 to the power 2 Newton per meter square or 100 pascals. Understood? Yeah, they are correct. Correct. Charu, I am too engrossed in teaching today, so I am not looking into the chat box much, but I am seeing them and continuing with my teaching. Everything you're writing is correct. Okay. Okay. Now Pratham asks me, what is the difference between force and thrust? You joined late or what? We started with that. Here I can take you back. Okay. We come back. Just a minute. We come back. We'll have to go a long distance back. And there we have it. Okay. These yellow arrows are representing a force. Okay. So on this surface, I could have force acting in any direction. You can see, okay, there I have shown you 3 different directions, and then the red one is the thrust. Okay, so red one also is a force. It is also a force, but it is acting perpendicular to the surface. So a force, if it is acting perpendicular to a surface, it's called thrust. Thrust also is a force. The only difference is its direction. Got it? If the direction is perpendicular, then we say that is the thrust. I can show you how 2 bodies of different masses, okay, they can have a different thrust. Let's take an example. Now I come back and I show you. Okay, so now I have a surface over here, and I have now, okay, the surface over here, and I have the inclined plane over there. And now I take a body. Okay, let's take a body. I take a small body, okay, of mass m. I take a small body whose mass is m, and this now it is put on an inclined plane at an angle of theta. Okay, so now this body is still lying over here. So the mass is the same. Okay, the acceleration due to gravity also is the same. Okay, so now I tell that the thrust in the 2 cases, I said that the thrust in the 2 cases is different. Okay, the thrust in the 2 cases is different. How is it different? In this case, the weight will be acting at its center of gravity and towards the earth. Okay, so now you can see that in this case, the weight of the body, which is equal to mass into gravity, okay, is acting perpendicular to the surface. This is acting perpendicular to the surface. Okay, so suppose I say that let's take that the body is of 10 kgs. Okay, I say that the body is of 10 kgs, and I take the acceleration due to gravity, the mass 10 kg, acceleration due to gravity. To make the calculations easy, I keep it 10 meter per second square. So in this case, the force or the thrust which is acting on the body is 100 newtons. Okay, now what is the case in this? Okay, now again, if you see that the weight of the body will be acting like this over here. Okay, but now the surface is inclined like this. Okay, I made the surface inclined, which means that this weight now is not perpendicular to the surface. It is not perpendicular to the surface. Okay, which means that I have to derive its component. I have to derive its component, which is perpendicular to the surface. Okay, you'll study this in higher classes, that we can always find out the components in different directions of a force. Okay, for example, you have a body which you are pulling like this. Okay, and the body's displacement is in this direction, so I also need to find out the component of force acting in the same direction. Got it? So here also we are doing the same thing. Okay, the weight of the body is acting like this. Let me change the arrows to make it more clear. Okay, the yellow arrow is showing, and I need the component, which means I need this red one. I need this red one. So how do I go about it? Okay, now if you see that this was 90 degree, okay, this was theta, so this becomes 90 minus theta, which means this becomes 90 minus theta, which means this becomes theta. Okay, so this angle is theta, so I can convert this weight in the component, okay, acting in the direction of the red arrow. And how much that does that become? Okay, if I look into this triangle, if I look into the red triangle, okay, if I look into the red triangle, then this is the weight of the body acting downwards. Okay, this arrow is the weight of the body, and I need the component in that direction. So I take the ratio cos, okay, curly brown here, so which means that the component this side will be mg cos theta. Okay, now suppose that this was inclined at an angle of 60 degree. I say that it was inclined at an angle of 60 degree. Just a minute. Okay, I say that it was inclined at an angle of 60 degrees. Then this also becomes 60, which means now my thrust is equal to mg cos 60 degree. Okay, which means it becomes 100 into 1 by 2. Okay, which means my thrust in this case is 50 newtons. Okay, so you have understood now. I hope you have understood now. Okay, that theta is this thing. She's asking what is theta. We use it to represent an angle. It's a Greek letter. We use it to represent an angle. Okay, theta. Got it, Charu? And we can derive the vertical component and the horizontal component of a force. Got it? So we are here deriving the vertical component as compared to the surface. Okay, so the mass of the body was same, the acceleration due to gravity was same in both the cases, but you see that when the surface is inclined, then the thrust changes. Okay, so thrust is the perpendicular force acting on a body. I hope you have understood. You'll be studying this in detail in class 9 when I teach you this work, power and energy. Got it? तो अभी खाली उसने पूछा था कि थ्रस्ट और फोर्स में क्या डिफरेंस है, तो मैंने एक एग्जांपल लेके आपको पूरी कैलकुलेशन दिखा दी कि अगर मास सेम है, एक्सेलरेशन ड्यू टू ग्रेविटी भी सेम है, लेकिन सर्फेसेस का एंगल डिफरेंट है, तो थ्रस्ट मेरा डिफरेंट हो जाता है. ओके, आपको अभी उतने डिटेल में समझने की ज़रूरत भी नहीं है, बस आपको इतना समझ में आना चाहिए कि जो थ्रस्ट है वो परपेंडिकुलर फोर्स है. ठीक है, फोर्स जो बॉडी के परपेंडिकुलर है उसको हम थ्रस्ट कहते हैं. ओके, सो वी हैव डन बार एंड मिली बार ऑल्सो. नाउ हम जो एटमॉस्फेरिक प्रेशर मेजर करते हैं उसका यूनिट होता है ATM. ओके, एंड व्हाट इज 1 ATM इक्वल टू? 1 ATM इज इक्वल टू 0.76 meters of mercury column, okay, or और इट इज़ 76 सेंटीमीटर्स ऑफ mercury कॉलम. ठीक है, विच मीन्स जब मैं एक mercury का कॉलम रखता हूँ, ओके, तो एटमॉस्फेरिक प्रेशर को उसकी जो लेंथ है 76 सेंटीमीटर्स के बराबर, उसकी जो लेंथ है वो एटमॉस्फेरिक प्रेशर को बैलेंस करती है. अंदर इसके mercury है, ओके, एंड दिस इज़ नोन एज 1 atm एट सी लेवल. जब हम सी लेवल पे ये नापते हैं तो 76 सेंटीमीटर्स mercury बैलेंस कर लेता है एटमॉस्फेरिक प्रेशर को, एंड दैट इज़ नोन एज 1 atmosphere. ATM is the symbol. Okay, in honor of the scientist Torricelli, हम इसको टॉर भी कहते हैं. So 1 torr is equal to 1 millimeter of Hg. Okay, so we can say that 1 atm is equal to 760 torrs. Okay, 1 atm is 760 millimeters, so it is becomes 760 torr. 1 atm is equal to 760 millimeters of Hg, which means that 1 atm is equal to 760 torr. ठीक है, so 1 millimeter of Hg is known as 1 torr. समझ में आ गया? Everybody understood? Okay, now we go to our second topic, which is the only topic which we are going to do for the day, and this topic is factors affecting pressure. Okay, factors affecting pressure. हमने ऑलमोस्ट समझ लिया है, ठीक है, कि जो प्रेशर है दैट इज इक्वल टू थ्रस्ट अपॉन एरिया. ओके, तो अगर मैं थ्रस्ट बढ़ाता हूँ तो मेरा जो प्रेशर है वो बढ़ जाता है. वेरी सिंपल, मैंने फोर्स बढ़ाया, मेरा प्रेशर बढ़ गया. ओके, एंड इट इज़ इन्वर्सली प्रोपोर्शनल. हमें दिख रहा है कि इट इज़ इन्वर्सली प्रोपोर्शनल टू द एरिया. और हमने नेल वाला एग्जांपल देख भी लिया. ये हमने नेल वाला एग्जांपल देखा था. ओके, कहाँ गया? ये रहा नेल वाला एग्जांपल. ओके, अगर नेल पॉइंटेड है तो प्रेशर ज़्यादा है, एरिया छोटा है तो प्रेशर ज़्यादा है, एरिया बड़ा है तो प्रेशर कम है. ओके, यहाँ पे एरिया छोटा है, प्रेशर ज़्यादा है, नेल बोर्ड के अंदर चली जाती है. यहाँ पे एरिया बड़ा हो गया तो प्रेशर कम हो गया. ओके, सो द सेकेंड फैक्टर विच ऑन विच प्रेशर डिपेंड्स इज़ द एरिया, एंड इफ़ द एरिया इज़ ग्रेटर द प्रेशर इज़ लेस, and if the area is less the pressure is greater. Okay, हम इसको calculations करके एक example से समझते हैं. Okay, तो अब मेरे पास वापस हम उसी example पे चलते हैं. हमारे पास surface है और उस surface के ऊपर हमने brick रखी हुई है. Okay, और पहले केस में हमने brick को लिटा के रखा हुआ है. Okay, like this. So हम इसकी डायमेंशंस भी लिख लें. ओके, अब ये जो है दिस इज़ 20 सेंटीमीटर्स और इसकी जो हाइट है वो है 5 सेंटीमीटर्स और इसकी जो ब्रेड्थ है वो है 10 सेंटीमीटर्स. ओके, अब इस केस में हम यहाँ पे क्या करते हैं, यहाँ पे हम इसको लंबी खड़ी कर देते हैं लाइक दिस. ओके, हम इसको लंबी खड़ी कर देते हैं, विच मीन्स नाउ this is 5 centimeters, okay, and this is 10 centimeters, और जो हमारा 20 वाला हिस्सा है वो लंबा ऐसे ऊपर खड़ा हो गया. ओके, उसके बाद हम इसका मास लेते हैं. हम इसका मास लेते हैं, कितना मास दिया है? 4 kgf. ओके, तो हम इसका थ्रस्ट ले रहे हैं. थ्रस्ट इज इक्वल टू 4 kgf. Okay, so in both the cases it is going to act downwards. So this case also it is 4 kgf, and here also the center of gravity it is going to act downwards 4 kgf. Okay, so मेरा thrust दोनों cases में same है. क्या मेरा pressure same है? I got to find the pressure. Okay, pressure is equal to thrust or force upon area. Okay, this is P1, so this is P2. P2 also force upon A2. This is A1. तो यहाँ पे थ्रस्ट कितना है? 4 kgf है. एरिया कितना है? एरिया है 20 into 10. 20 इसको मीटर में कन्वर्ट करना पड़ेगा. ओके, सो इसको मीटर में कन्वर्ट करना पड़ेगा. सो 20 by 100 into 10 by 100. Okay, so how much does it become? It becomes 4 into 0000 by 200. These two zeros cancels. Okay, so it becomes 200. Okay, 200. So this becomes 200 kgf per meter square, and we're going to find this one now. Okay, इसमें हम फाइंड करें तो कितना आया, फिर से 4 हुआ. एरिया इसमें कितना हो गया, 5 into 10. So 5 by 100 into 10 by 100. Okay, so it becomes, this becomes 40000 by 5 tens of 50. So this 0 cancels, and what do I get? I get 800 kgf per meter square. Got it? So आपको दिख रहा है कि जो प्रेशर है वो ऑलमोस्ट 4 गुना बढ़ जा रहा है. ओके, प्रेशर ऑलमोस्ट 4 गुना बढ़ जा रहा है जब उसका एरिया कम हो रहा है. यहाँ पे एरिया है कितना, 200 सेंटीमीटर स्क्वायर. ओके, और दूसरी तरफ एरिया क्या है, दूसरी तरफ एरिया है 50 सेंटीमीटर स्क्वायर. तो जैसे ही एरिया 4 गुना घटा, 1/4 हुआ, वैसे ही मेरा प्रेशर 4 times बढ़ गया. The area became 1/4 and the pressure became 4 times. Okay, so how can I increase pressure? I can increase pressure by either increasing the thrust. मैं ज़्यादा फोर्स लगाऊंगा तो ज़्यादा प्रेशर हो जाएगा, या फिर मैं एरिया घटा दूं. जितना मैं एरिया घटाऊंगा उतना ज़्यादा प्रेशर हो जाएगा. ठीक है, समझ में आ गया? बस आज इतना ही पढ़ाऊंगा. और कुछ है इसमें, देखें आपकी बुक में ना, प्रेशर एंड फ्लूइड्स आ गया इसके बाद. तो आज हम इतना ही पढ़ेंगे. आई होप यू हैव अंडरस्टूड द डेफिनेशन ऑफ प्रेशर. आई होप यू हैव अंडरस्टूड what is thrust. I hope you have understood the units of pressure and the factors on which pressure depends. Right? Today the number of students also is very less, so I don't want to go into fluids because ultimately this chapter is about pressure and fluids. Okay, this pressure and thrust and fluids, this units, so you had studied it in the previous classes also, so it was just like recapitulating on what we had learnt in the previous classes. Okay, so thank you very much. We'll continue from here in the next class. Bye bye, see you, good night.